In this video, we're going to talk about integration of trigonometric functions. Now, if we integrate sine x with respect to x, we're going to get negative cos x plus c constant. If we integrate tan x with respect to x, we're going to get negative n cos x plus c. If we integrate sec x with respect to x, we're going to get n sec x plus tan x plus c. For the sake of time, I want to pause the video to write out the next, so you yourself can pause the video and know them before we use them to solve questions. So these are some of the identities of integration of trigonometric functions. So you can pause the video and write them out because we need to know it. Now let's go straight and solve some questions. This question says integrate cos bracket 3x plus 9 with respect to x. Now we can see that 3x plus 9 is already in a bracket on its own. So since it has x, we can call it one identity and say let 3x plus 9 be called u. So because of that, if we differentiate u, we are going to get 3 with respect to x. So we can rewrite this question by saying 1 over 3, because it doesn't have x again, integral of cos u with respect to x. So since this is what we're going to integrate, and remember that whenever we integrate cos, we get sine. So because of that, we get 1 over 3 sine u plus c. Now, we already know that u is 3x plus 9, so we can rewrite it and say 1 over 3 sine, instead of writing u now, we can say 3x plus 9 plus c. That is the answer. We have integrated the question. Another question says integrate tan x sine x with respect to x. Now, we don't want to first of all go and start integrating tan x on its own, because if we integrate tan x, we're going to get negative n cos x plus c. So it will really take us out of the scope of this question. So because of that, we can interpret tan x on its own, because fundamental identity says that tan x is equal to sine. Recall that tan x is equal to sine x over cos x. So we can break that into this equation, this question, I beg your pardon. So we can have integral of sine x over cos x, then this sine x, because this is tan, then this sine x, we can still say dx. So we have integral, sine times sine gives us sine squared x over cos x dx. Now, sine square x, according to fundamental identity also, can be rewritten as 1 minus cos square x. Now, because of that, we can say integral of 1 minus cos squared x over cos x dx, because this is the same thing as sine squared x, fundamental identities. Now, because of that, this cos x is for two of them, so we can separate them by saying integral of 1 over cos x minus, or you can still give it its own dx, minus this person, integral of cos squared x over cos x dx. Let's make use of this side. Having gotten to this place, if I integrate 1 over cos x, I will get sec x. So because of that, or no, if I have 1 over cos x already is sec x, so we can say integral of sec x, because this is the same thing as sec s. So sec x dx minus one of these will remove one of these, so we'll have integral of only one is remaining, cos x dx. So because of that, if I now integrate sec s, I'm going to get in sec x plus tan x. So sorry, I had to rewrite it. I'll have integral of sec x dx minus integral of cos x dx. So if I integrate sec x with respect to x, I will get in sec x plus tan x. If I integrate cos, I will get sine, so minus sine x. So once I have done that, I don't think I can go any further. I will just now have to add plus c, and that is the answer. Another question we can look at is integrate sine squared x over cos squared x with respect to x. Now, we need to recall, before we solve, we need to recall that sine x over cos x is equal to tan x. Since we know that, it means that this can be rewritten as integral of tan square x dx. Once we know that, we also need to recall that tan square x under fundamental identity is the same thing as sec square x minus 1 under fundamental identity. So I can use this to replace this by saying integral of sec square x minus 1 with respect to x. So with that, I can split them. If I split two of them, I will have integral of sec squared x minus integral of 1 with respect to x. Whenever I integrate sec squared x, I will get tan x. So if I integrate this, I will get tan x. If I integrate 1 with respect to x, I will get x, so minus 1. Sorry, I will get x minus x plus c. So this becomes the answer. So please, if you've not subscribed to my YouTube channel, please try do that. Thank you.